And welcome back to my channel Unbound Coder. Here we break the limit with code. So today we will see that the common DP on string problem, that is the longest common subsequence. What is the subsequence means? The subsequence is subsequence and substring both are different. Subsequence each means they follow the only order, and substrings what substring is continuous. Substring is continuous. Okay, if you see A B C D, so I D C D B C D A B C D, this is for substring, this is continuous. And if you write subsequence, then it only subsequent or subset, it only follow the order, means A B C D. So A after A, after A then also came C, not C came before A. Okay, so AC is the subsequence, BD is the subsequence, ACD is the subsequence. Okay, so here question say that longest common subsequence. Here if you see that our A, here not any A, B, yeah, present, C not present any C, D, yeah, D present. Okay, so here the answer is BD. So how you do it, by DP, dynamic programming. So you use two pointer. Okay, start from here. Okay, start from here and check if my character same, drf not same. So what I do, I simply want anyone, if it or if it anywhere, I just decrease it. Okay, first of all I decrease that. So I check a for c not match. Okay, then I also decrease b. Okay, that's type. Okay, then a b or f not match, then a or f not match, so again it is came in d. Okay, so now came here. This also came here. Here also C E, there is no E. Also again came D. When both are matched, D and D is my match, so ki both pointer also increase same time. Okay, okay, again BC not match, also here came. Okay, again if you see BB match, and it's present here. Okay, and my longest also count, if when both are same, then also count 1 plus, okay, 1 plus another function call. Okay, I see you in code. Then also last, then also came last, and when anyone came exhausted, then return 0. Okay, so I see you in code. Here first of all see the base case. What is my base case? If my A B C D and B D E F. Okay, so if anyone exhausted, S1 exhausted or S2 exhausted, okay, return 0, nothing give me answer. Okay, if both are same time exhausted, then it will return 1. Okay, so I not write it, I only write that main which give me my answer. Okay, so if I write the function, first of all I do recursion. In recursion you also make the recursion tree. There are also me two choice, if same or if not same. If same, so both are reduced same, and if not same, then one reduce, one stay, and again another reduce and another stay constant. Okay, so if I write the code, so I write function of n minus 1. N means my string s1 size, and m means my s2 size. Okay, so n minus 1, m minus 1. Okay, 2 index and string 1 and string 2. First of all check the base case. If my I 0 or j also less than 0, return 0. Okay, okay, then you write if my s of I, you write the function that it is my I and it is my j. Okay, okay, so now if see, if s of I equal to my s of j, then you write that my, what is my answer, return 1 plus dp, or not here use dp, here only function. So function of, then both are same, both are reduced, so I minus 1 and j minus 1 also reduce, and s1 s2 pass. Okay, okay, Then if not match, what I do, I if not match, then nothing give me answer, but I am sure that any of the give me the maximum value. Okay, so what you will see, you write that my return my answer, return my maximum of, means you write 0, anybody will not give me the answer, so I 0 plus function of, here you write maximum of anybody, if I want constant another reduce, if another constant, or again this is reduce. Okay, so a maximum of function of I minus 1 comma j constant, string 1 and string 2, and another of if I comma, for maximum find I I is constant j minus 1 string 1 and string 2. Okay, if you use this you find the answer. Okay, so by it you see that time complexity is my exponential. Why it exponential? Because it's all time function call, so I not use it, I use recursion to memoization convert. So in memoization you see that how what the dp we need, which dp I need. Here you see the changing parameter, here changing parameter is 2, so I need 2d dp. So first you write a dp with n size or m size. Okay, and write minus 1 initialize. Okay, n and m size minus 1 initialize. Then when the function call, here we you check if my dp of ij not equal to minus 1, then you simply return, then you simply return return my dp of ij. Okay, okay, here you write return dp of ij value. Okay, here also you write return dp of ij value. Where give me the answer, this is my value. Okay, and if you see that this also give you answer, but I for tabulation I teach you another thing, that is shift index. Because if you see that I when means when I is less than 0, so if I any assumption pick that my last value a b c d. Okay, so my last value, if I assume this is my n, and I this is the boundary out of bound, so out of bound I pick it 0, so then it will be possible that I equal to 0 and j equal to 0, this is my base case, so this give me answer. So obviously it's also possible. So then what I need, then n plus 1 size and m plus 1 size dp array we need. And also check when my I equal to 0, here right, when I equal to 0 and j equal to 0, any of the return 0. If not, then also same method, not any problem, same method. But here you see that n is my this. Okay, so here also need reduce one thing, means here is my s of I, s of I, the seen that n, because this is my 0 index, so what I need, I need I minus 1, because you see that minus 1 also converted in 0. So if I shifted it all, then when I from traverse from last to first, I see that need minus 1 check, also this is n plus 1 2, so need minus 1 check, if it was then same to same. Okay, okay, thus check the longest common subsequence using memoization. Okay, so if I use tabulation, then what I do, if I do tabulation, if my memoization is top down approach, then my tabulation is bottom up approach, top down to bottom up approach. But top down bottom up, what is say, my if you see my top down go n to 0 and go m to 0. For s1 it's go n to 0, and for s2 it go m to 0. But in bottom up it is opposite. For bottom up it go till 0 to n and 0 to m. Okay, so again we need the to 2d dp. Here we initialize the dp is 0. Okay, then what you do, then you write that my base case check, base case what, that base case is the any of I, if my j is 0 means exhausted, so then 0, and when my I exhausted but j anything, then return 0. Okay, and every time for loop you I from which 1 to 0 cover already, so I want to greater than equal to m, because I my base case is 0, so I greater than equal to n, so I need n plus 1 size dpl. I see you previous, so you in previous. Okay, so then my another loop for j equal to 1 to greater than equal to m. Okay, okay, and you write if my s1 of I minus 1 equal to s2 of my j minus 1, if it's same, then what you write, my dp of ij equal to 1 plus dp of I minus 1 and j minus 1, both are reduced same time. Okay, and if not match, then what you write, else you write that anything means my dp of ij equal to maximum of means 0 plus 0 anybody, so dp of I minus 1 comma j and dp of comma I comma j minus 1. Okay, and lastly return कर दो dp of n comma m. बस, this is my answer give. So here time complexity big O n square and pace complexity big O n square, because in with tabulation I reduce the pace. Okay, so it also possible pace optimization also. So what you where now I say you in every video that where you see I minus 1 I minus 1 I minus 1, then you change it previous. Okay, where I minus 1 you need to add a previous or current, here you write current and here you write previous. Okay, and your pace optimization also possible. Then what need big O n my pace complexity and my time complexity big O n square. So for using this question you will solve maximum of dp on string problem. So this problem are I say you, one is longest common subsequence that I show you now, another is longest common substring. They are nothing, they are only here case that one length each peak. Okay, here you maximum need, there you only length peak means here you write that length equal to my 1 plus this, so my answer equal to maximum of my previous answer and length, and if not match then you write just maximum, not need to maximum, just write dp of ij equal to 0. Okay, okay, that is my case. And also you solve the longest palindromic substring, minimum insertion and to make the palindrome, also you solve the deletion make same string. These are the same problem. Okay, same problem, same approach, only need simple tricky change. Okay, so I show you another problem, you you search in your brain. Okay, how you solve it. Okay, so this is the gfg problem. The problem say that minimum number of deletion and insertion need to make a string 1 to string 2. So I show you that my s1 is heap. Okay, and my s2 is pa. Okay, so now say from convert hep to pa, how much operation need here means delete or insert to make the same string. So what you do approach here, you thought first you see that this is my common. Okay, so I don't delete it. Okay, now you see that I have this string means size 4, my common 2. Okay, plus for this my size is 3 but my common 2. So if I calculate it, my 2 plus 1 equal to 3. You see that I delete h 1 operation, delete p 2 operation and add a p 3 operation. This is my answer. So this problem I show you in my laptop and you see that. Okay,